This is Ham College, episode 90 for June 30th, 2022. This episode of Ham College is brought to you by ICOM. Keep your competitive contesting edge with ICOM. Good evening. Welcome to another exciting episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And great to be back with you again tonight. Happy Canada Day, eh?
Happy Canada Day.
And happy 4th. It's that
hoser.
Okay. All right. So you can see which way the show is going to go tonight. It's that time of year, though. Everybody's out blowing up fireworks in their hands and
terrorizing my dog.
Yep, all of that stuff. We are studying the amateur extra exam here, and we've got some, I was going to say unusually tough, but no, they're all tough.
Yeah, it's been kind of the running theme lately.
Yeah.
We had a couple months ago, we had one that wasn't too bad.
Yep. This time last week, I was loading up the truck preparing for field day.
Yep. This time last week, I was still scrambling around trying to find all my stuff.
Well, same here too, yeah. I think I was actually sitting right here and I had the rig I was going to use and my laptop and everything out, trying to get everybody to play nice.
Yeah, you must have succeeded.
That's sort of. One of the parties just didn't want to play at all, so I didn't use it. So, and that's why you noticed my frequency wasn't updating on the log there. But anyway, we got that squared away. We had a good field day. We're going to be talking about that in the next Amateur Logic around the middle of July here. So come back then. We've got some video segments and different things. We did a little bit different this year than normal. But
it was the conditions. I don't want to tell too much, but the conditions or the accommodations were much improved.
Yes, all except the part about putting the antennas up.
Yeah, that was tough.
It always is, and it's always hot here. But anyway, enough about that. So, Dean, what was in the last show?
I remember it was a mouthful, and there were a lot of tongue twisters in there. But I did not print out my cheat sheet, so why don't you fill us in?
Well, actually, I think it was toroidal and solenoidal inductors.
Those are the tongue twisters I was talking about.
Permeability, core materials, selecting winding transformers, piezoelectric devices.
Hey, this time, why don't we talk about analog ICs, MMICs, IC packaging characteristics, to name a few.
Sounds good to me.
May as well. Seems like a good topic.
We're going to get in on to the questions tonight because there are some difficult ones in here.
How come you didn't tell me that before I drove over here?
I didn't want to do the show by myself. So I think we actually are probably going to have to get a real coin, or at least a faux coin, to flip to determine who's going to receive tonight. So I'll let you flip I'll flip, you choose.
Okay. Heads.
It is heads.
Okay, so I'll go ahead and answer the first one. It doesn't matter.
Okay. Why is gallium arsenide useful for semiconductor devices operating at UHF and higher frequencies? A, higher noise figures.
B, higher electron mobility.
C, lower junction voltage drop.
Or D, lower transconductance. Why is gallium arsenide useful for semiconductor devices? UHF and higher. UHF and higher. It's going to be C or B, but I'm thinking it's going to be B, because if I'm reading that, that would mean the better conductivity. Those higher frequencies, that lower junction voltage drop. I don't know. I'm guessing B.
You're guessing B. Well, the chat room is saying it's either B, C, or E.
E. I'm going with E. Or
All
B,
right.
since that's the only one.
Well, you said B.
Sounds like it.
Seems like a pretty good guess. And it is. There you go. All right. So off to a good start here tonight. Maybe I won't have to pull out the wall wart for the buzzer after all.
Oh,
Maybe
there's
there's
going to run the battery down?
Yeah.
I don't know. Still time. The night's still young.
You got a question for me?
I do. I got a good one right here. Although you're probably going to know the answer to this one. Which of the following device packages is a through-hole type? A, a DIP, DIP.
B, a PLCC.
C, ball grid array.
Or D, an SOT. That last one just sounds like an insult, doesn't it?
It does.
Yeah. Well, I do happen to know the answer to this because
Well, I think I know the answer to this one.
I think everybody probably knows the answer to this. This is going to be the easiest question tonight. I'll put it that way.
I knew I should have got the second question instead of the first one.
Well, yeah, you did okay. I know a DIP is referring to a DIP package, or those are those chips that we used to get at Radio Shack or all the early chips where you had a socket to plug them into, or you had holes drilled in the PC board and you put the leads down through it and soldered them. That's definitely a through-hole type, so I'm going to say it's A, DIP.
That's got to be it.
Everybody in the chat room is saying A, so there you go. That's got to be it. And it is.
Nailed it.
Okay. I was just saying what a DIP chip is.
Mm-hmm.
Chip. I did say chip. There's a typical DIP chip. That's 1, 2, 3, 4, 5. So that's 14 pin right there. Can you tell me which one is pin 1, Dean?
If it's the second one, I think it would be the top left one.
Did you hear that?
Buzzer?
Yep. It's the bottom left. That would be pin 1.
Okay.
And you count them across the bottom.
With the indentation on the left.
Yeah, so you count them the bottom left to right, so that'd be 1 through 7. And then you go straight up, and then that's 8 through 14, going back the other way. So, let me just say, if you put it in backwards, it does release the magic smoke.
Yeah, you only do it once per chip.
Yep. This is a perfect question for you right here. I mean, I just feel it. It
scares me when you say that.
I feel it coming because I know it wouldn't be a good one for me. Which of the following materials is likely to provide the highest frequency of operation when used in MMICs? Is it A, silicon?
B, silicon nitride?
C, silicon dioxide?
Or D, gallium nitride? I guess I'm pronouncing that right.
I think so.
Well, since how gallium was in the last one, I'm thinking I'm going to go with D.
Okay.
And that's the only reason.
All right. Well, let's see. I'm not sure if it's a good reason, but
this all matters. Depends on if it works for me.
Well, there you go. Everybody in the chat room saying D, so I think you're probably on to something. And it is gallium nitride. So what is an MMIC?
You know, I looked that up earlier and I don't even remember. Why don't you enlighten us,
Well,
Professor?
I tell you what, Wikipedia is going to enlighten us. 'Cause I
Okay.
just happened to copy some stuff out of it on here. These are going to be some tougher questions tonight. I'm sure all our people out there in the chat room already know the answers to these questions, but maybe for those who are watching later who weren't in the chat room tonight don't know the answer. So if we go over this stuff now, it's going to make the rest of the questions go down a lot easier. An MMIC is a monolithic microwave integrated circuit. Sometimes it's pronounced Mmic. It's a type of integrated circuit that operates at microwave frequencies, and they're saying here 300 megahertz to 300 gigahertz. I don't believe microwave frequencies start at 300 megahertz, but you can see MMICs starting to be used around that frequency. These devices typically perform functions such as microwave mixing, power amplification, low noise amplification, and high frequency switching of inputs and outputs. MMC devices are frequently matched to a characteristic impedance of 50 ohms. This makes it easier to use as cascading the MMICs does not require external matching networks. Additionally, most microwave test equipment is designed to operate in a 50 ohm environment. MMICs are dimensionally small and can be mass produced, which has allowed the proliferation of high frequency devices such as cellular phones. MMICs were originally fabricated with gallium arsenide. It has two fundamental advantages over silicon, the traditional material of ICs, like transistors. The advantages of gallium arsenide are speed and semi-insulating substrate. Both factors help with the design of high-frequency circuits. However, the speed of silicon-based technologies has increased gradually as transistors' feature sizes have been reduced, and MMICs can now also be fabricated in silicon. Originally, MMICs used metal semiconductor fill effects transistors as their active device, and more recently, high electron mobility transistors, pseudomorphic HEMTs, and heterojunction bipolar transistors have become common. Other technologies such as indium phosphide have been shown to offer superior performance to gallium arsenide in terms of gain, higher cutoff frequency, and lower noise. However, these tend to be more expensive due to the smaller wafer size and increased material fragility. That's Italian, isn't it?
Fragile.
Silicon germanium is a silicon-based compound semiconductor technology offering higher speed transistors than conventional silicon devices, but with similar cost advantages. Gallium nitride is also an option for MMICs, because gallium nitride transistors can operate at much higher temperatures and work at much higher voltages than gallium arsenide transistors, and that makes them ideal power amplifiers at microwave frequencies. So there you go. More than you ever wanted to know about MMICs.
Way more.
Yeah. VE3 MICs are much easier to understand.
That's true.
So if you were paying attention there, you'll probably know a lot of the answers on some of the other questions. Otherwise, it was going to be a long night, and I know there's not enough life left in that battery in the buzzer.
Yeah, we
got
killed
us
them all
through.
at field day.
Yep, pretty much. So with that, let's see. You answered the last one, so
Which is the most common input and output impedance of circuits that use MMICs? A, 50 ohms.
B, 300 ohms,
C, 450 ohms.
or D, 10 ohms. Which is the most common input and output impedance of circuits that use MMICs? Well, 300, 450, or 10 ohms really wouldn't be good impedances. So if you had a choice, you'd want to do them at 50 ohms, and I think they must have had a choice.
They must have.
And that's what I would choose right there. So I'm going to say it's A, 50 ohms. The chat room, oh yeah, they're saying A. So
They must have been paying attention when you read the article a few minutes ago, too, because that was in there.
Yeah, A good point there. And yeah, it is A. Which of the following noise figure values is typical of a low noise UHF preamplifier? Is it A, 2 dB,
B, minus 10 dB,
C, 44 dBm?
or D, minus 20 dBm? This is my turn.
Yep.
Typical values of a low noise UHF amplifier. I'm gonna go with A because it's positive number.
Okay.
I really don't know the answer.
But you're saying it's A.
I don't think a 44. That's pretty high. I think it's gonna be A or B. I'm gonna go with A.
Okay.
I just really don't have any idea.
Based on the chat room, we've got A's and B's. So.
Well, maybe I'm close.
It is. It's 2 dB.
2 dB.
Yep.
Arnie says, look like I haven't studied the new question pools, but I don't study them because then it kind of sort of takes, if you sat here and everything got right, it'd be kind of boring, I think.
Yeah, Tom points out a good point here. Noise figures can't be dBm because those are powers, not ratios. Yep.
That makes sense.
All right. Let's see. Where are we? I think we got another question here.
Okay. What characteristics of the MMIC make it a popular choice for VHF through microwave circuits? A, the ability to retrieve information from a single signal even in the presence of other strong signals.
B, plate current that is controlled by a control grid.
C, nearly infinite gain, very high input impedance, and very low output impedance.
Or D, controlled gain, low noise figures, and constant input and output impedance over the specified frequency range.
Ew.
Well, let's rule out some things here. The ability to retrieve information from a single signal, even in the presence of other strong signals. This sounds like ad copy for a commercial I did a while back. So no, I don't think that's it. It's, MMICs, I don't think will help you there. B, plate current that is controlled by a control grid. Well, I think we know that MMIC is a monolithic microwave integrated circuit. So there is no control grid. You got plate current and a control grid in a tube, so definitely not that. C, nearly infinite gain, very high input impedance, and very low output impedance. You would think maybe, but
D seems
since we know that we have constant input and output impedance over the specified frequency range, low noise figures, and control gain, well, I wasn't sure about that, but I know the rest of those make sense there. So I'm going with D. Control gain, low noise figures, and constant input and output impedance over the specified frequency range. That would sure make higher frequency gear operate better, easier to design. So yeah, I'm going with D. The chat room, they like that answer too. So there.
No.
Keep your competitive contesting edge with ICOM. ICOM's high-powered base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA One app. Heard it, worked it, logged it. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. Create your own band opening with the IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. Faster processors, higher input gain, higher display resolution, and a cleaner signal. 4.3-inch color touchscreen TFT LCD, real-time high-speed spectrum scope, and waterfall display. Smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. ICOM's IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The ICOM 7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR transceiver. RF direct sampling system, 110 RMDR, independent dual receiver, dual digicell. ICOM's IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. Learn more about all these great ICOM radios at icomamerica.com/amateur.
We want to thank ICOM for sponsoring Ham College. And got a little announcement here. Ray sent an email out earlier. Want to remind everyone that the Warbirds Board of Directors will be sponsoring a special event station during EAA Air Ventures 2021 on July the 25th through the 31st. All Warbirds members with current amateur licenses are invited to operate on W9W during daylight hours. Non-licensed Warbird members may participate under the supervision of a licensed amateur operator. The station will be located on the Warbirds grounds near Warbirds HQ. ICOM America will be supporting the event with HF, VHF, and UHF radio equipment. Other sponsors include Heil Sound, Radio Waves, DX Engineering, and US Towers. If you would like to get on the schedule to operate W9W this year, contact Ray, N9JA, at icomamerica.com. They'll get you on the schedule.
Cool. I'll have to listen for that.
So, what do you say we give away something? I notice you've got an extra shirt there.
Yeah, I do have one. And thanks to ICOM for sponsoring us, so we're going to give away some of their stuff. So, nice Ham Crew t-shirt. Look just as good when you leave the Ham Fest as you did when you got there. Good night.
Yeah, that makes sense. I had to think about it.
Yeah.
Yeah, that makes sense.
Okay.
So,
and it's the slogan's even professor approved.
So
nice, good shirt.
If you wanted to win this, well, just drop us an email, hamcollege@AmateurLogic.TV. And you got to have a name and you got to have an email address. You don't have to be a ham. And that's all the qualifications there. You can drop a little message in the email if you like. That's always nice, or you really don't have to. Just up to you. But the winner for this month was drawn before the show tonight. And it is Craig Emmett, N1KY. Congratulations, Craig. And
yeah, congrats.
And Tommy, he actually left a message here for us.
All right, that's good. I like that.
Howdy, Professor Thomas and Dean Martin. Love the show. Have been watching since episode 1. Please enter me in this month's contest for the sweet ICOM swag. There you go, Craig. Some sweet swag coming your way. If I just had one more S, that would have been...
Say that 3 times real fast.
Some sweet swag shirts coming your way.
Yep, congrats.
Yep.
If you didn't win and you'd like to try again, the queue gets cleared out after each drawing. So you could welcome to enter again for next month. So maybe next month will be your lucky month.
What type of transmission line is used for connection of MMICs? A. Miniature coax.
B. Circular waveguide.
C. Parallel wire.
Or D. Microstrip. You know, I seem to remember this one. I think. What type of transmission line is used for connections to MMICs? I think I remember this one from my test, but I believe it's going to be microstrip D. I don't even know what microstrip is, but I do remember that. I'm going with D.
Okay. You're in good company. Everyone in the chat room, and I do mean almost everyone, is saying D. They're answering this question.
Well, it would have been pretty embarrassing if I'd have said something else then.
Yep. We've got a lot more answers on this question than I think any other question tonight. So
you're saying there's a chance?
I'm saying there's a chance, and it is. It's microstrip.
I actually remember that.
This is a microstrip bandpass filter, but it's just little strips there on the PC board that tie everything together. You know, if you thought about it for a moment, it really wouldn't make sense connecting integrated circuits together with miniature coax, circular waveguide, or parallel wire. Microstrip, that would be the way to do it, right on the PC board there. And those are actually tuned circuits, so you have some tricks you can do as far as impedance matching and filtering and such by using microstrip.
How is power supplied to the most common type of MMICs? A. Through a resistor and or RF choke connected to the amplifier output lead.
B. MMICs require no operating bias.
C. Through a capacitor and RF choke connected to the amplifier input lead.
Or D. Directly to the bias voltage VCC in lead. How is power supplied to the most common type of MMIC? Directly to the bias voltage VCC in lead. That sounds like a pretty good answer there.
To the most common
Through a
type.
capacitor and RF choke connected to the amplifier input lead. No, you're not going to be passing DC voltage through a capacitor, so I'm pretty sure that's not it. MMICs require no operating bias. You've got to have voltage or they're not going to, active circuit's not going to operate without some voltage. A, through a resistor and or RF choke connected to the amplifier output lead. Yeah. I'm going to say that, well, let's just see if it is first. Chat room.
Which one you saying, A?
Yes, it's counted today.
A.
A.
Well, there is a kind of a running theme with that, isn't it?
Yeah, keeps coming up, doesn't it? Little mix in the chat room there. Most folks are saying A. So let's see if we're right. And we are. And it just occurred to me as I was reading that there. That's kind of the same way that you would put plate voltage onto a tube.
Is it?
Yep. They run the high DC voltage through a choke or an inductor, and then that goes on to the plate of the tube so that the voltage can get through that choke, the DC can, but the RF can't come back down it because the choke will block it. So, yeah, man, that's just a coincidence because there's very little else in common with a vacuum tube, I would think, other than I guess they're both amplifiers. Which of the following component package types would be most suitable for use at frequencies above the HF range? A. TO220.
B. Axial lead.
C. Radial lead.
Or D. Surface mount. Which of the following component package types would be most suitable for use at frequencies above the HF range? I don't know what a TO220 is, so I'm scratching that off the list. I'm going with D, surface mount.
Okay.
That's really all I can say about that.
Well, that was enough.
What's a TO220?
A TO220 is a fairly common transistor package style. It's, well, we would call them flat packs or like a 7805 regulator chip or all those voltage regulator chips that have the 3 leads out the bottom and then a little mounting tab.
Yeah.
That's a TO220 style right
okay.
there. An axial lead and a radial lead, that's something you'd see on a resistor or a capacitor, where the leads are coming out either end of the package or they're both coming out one end.
Yeah. What advantage does surface mount technology offer at RF compared to using through-hole components? A. Smaller circuit area.
B. Shorter circuit board traces.
C. Components have less parasitic inductance and capacitance.
Or D. All of these choices are correct. What advantage does surface mount technology offer at RF compared to using through-hole components? Well, right off, A, smaller circuit area. Yeah, because surface mount technology is generally a lot smaller than through-hole components. B, shorter circuit board traces. Yeah, because you can put your components closer together because they're smaller. C, components have less parasitic inductance and capacitance. Yeah, because the leads are very short on them. So there's not much way to build up inductance and capacitance there, or it would be negligible anyway. So D, all of these choices are correct. And yes, all those are correct choices. So, what is a characteristic of dip packaging used for integrated circuits? A, package mounts in a direct inverted position.
B, low leakage, doubly insulated package.
C, 2 chips in each package, dual end package.
D, a total of 2 rows of connecting pins placed on opposite sides of the package, dual inline package. What the characteristics of dip packaging? Well, dual inline, two rows of connecting pins. It's got to be D. Leakage, doubly insulated, 2 chips, 2 rows of connecting pins. It's going to be D. We actually saw one of those types of chips earlier that describes the socket that it goes in.
2 rows of connecting pins placed on opposite sides of the package. Well, that's exactly what we saw earlier when we looked at a dip chip.
What'd you call?
Chip.
What'd you call me?
Chip.
Oh, okay.
Yep. DIP chip. There you go. And is this going to be the last one?
No way. Not so soon.
Why?
Why are dip through-hole package ICs not typically used at UHF and higher frequencies? A, too many pins.
B, epoxy coating is conductive above 300 megahertz.
C, excessive lead length.
D, unsuitable for combining analog and digital signals. Why are dip through-hole package ICs not typically used at UHF and higher frequency? Well, D makes no sense at all unsuitable for combining analog and digital signals. First, no dip packaged chips aren't unsuitable for that. They're used for it quite often, but that really doesn't matter. I mean, we've got analog UHF equipment, and we've got digital, but it doesn't matter if analog and digital can be combined with those chips. That's it's not even necessary in a lot of cases. Too many pins. No. I mean, a lot of surface mount chips have way more pins than a dip chip, so that's not it. B, epoxy coating is conductive above 300 megahertz. I don't think so. But this one makes sense. C, excessive lead length, because the length of the leads on a dip package are a lot longer than, say, on surface mount. So yeah, that one makes sense. I'm going to say it's C, along with everybody in the chat room. So there you go.
When do the questions about the chipstick come? Is that next month?
I think those were on the general exam.
The chipstick?
Yeah. Oh, wait a minute. That was on the Pine Board exam. That's when that was. So. All right. That's it. That's all the questions we've got on analog ICs, MMICs, and IC package characteristics.
Man, I might have to go lay down after that.
Yeah, you did okay.
We didn't have any buzzer, but it's a miracle. Another miracle.
Well, it is, and I think Wikipedia helped us out a lot there near the beginning.
Wikipedia helped tremendously.
Well, I guess we're going to get on out of here tonight. Tommy wants us to be sociable, so, and that's, we're basically sociable.
Basically?
Basically. So,
depends on your definition.
The next time we're going to be sociable is, it's coming right up.
Tuesday. AmateurLogic Soundcheck Net every Tuesday. This coming Tuesday will be the 116th, I believe. 116 weeks we've had that net. It's still going strong, so a lot of different ways to connect. If you haven't joined us and checked in on there, give it a try. I think you'll like it. It really is a lot of fun.
Yeah, a lot of different ways to connect right there. So join us. And I hear the fireworks. They had a balloon glow here in town tonight.
Oh, did they?
Yeah. And I guess that's the fireworks going from it now.
I usually go to that.
Do you? You missed it tonight. You probably got your feet wet.
Probably. But my poor dog's having a heart attack.
Yeah.
You can join us at our usual social media places as well. We've got a Facebook group at facebook.com/groups/Ham College.
Yeah, you can follow us at Ham College on Twitter.
We're also on MeWe, MeWe.com/join/Ham College.
Or groups.io/G/AmateurLogic. And you can join our Groups.io group if you just want to be notified when something's going on. That's basically all that gets posted on there. It gives you a little notice to let you know when we're going to be doing a live stream.
The net or the live streams, a few things like that.
Yeah.
So if you're not into the regular social media stuff, that's almost more like a mail list almost.
Yeah.
But it's pretty nice. A lot of people subscribe to that.
Yeah. So thanks for being with us tonight, everyone. We always appreciate it. And do study for your exam. There's going to be a test.
Yep. There will. And you're going to need to know what MMICs are.
Yep. Happy Canada Day. Happy 4th of July. And go Fighting Anodes of Ham College.
Yep. I guess we don't know what day Amateur Logic is, but we'll see you guys in a couple of weeks. Some of you.
Yeah. I'm not sure what day it's exactly going to be yet. Let's see. That is probably.
Nope, that's the wrong. Oh, yeah. That one. Oh, the 15th.
Could be on Friday the 15th.
Yep,
Sounds
most
like a good
likely.
possibility.
So hopefully we'll see you then.
Yeah.
73.
Live long and prosper. Actually, I think it was toroidal and solenoidal
Yeah, those are the
inductors,
tongue twisters I was talking about.
permeability, core materials, selecting winding transformers, piezoelectric devices, and stuff like that. You know. So, what are we going to... Other technologies such as indium phosphate or is it A, 2 dB?
C, minus 10 dB.
Did you say C or B? Which of the following component package types would be most suitable for use at frequencies above the UHF? Let me say that again since I was so far off. By megahertz. Hundreds of megahertz.